Good day, fellow SAT students, and welcome to our screencast. We are Quality Geeks, and we are first-year BTech quality students. Our screencast will cover the rules of normal distribution, including the empirical rule. One of the objectives of this screencast is to connect how normal distribution can be utilized in a quality environment. The content of this presentation will cover the following: types of data, normal distribution, properties of normal distribution, the parameters of normal distribution, rules of normal distribution, and finally, an example of how normal distribution can be utilized in a quality environment. Data types are an important concept because statistical methods can only be used with certain data. You have to analyze continuous data differently than categorical data. Otherwise, it will result in the incorrect analysis. The following diagram illustrates the various groups of data that is used in statistics. However, it is very important to understand that normal distribution makes use of continuous data. So what is continuous data? Continuous data can take on any numerical value, and it can be meaningfully divided into smaller increments, including fractional and decimal values. You need to remember that there are an infinite number of possible values between any two numbers. Typically, you measure continuous variables on a scale such as length, size, width, your weight, temperature, or even time. So what is normal distribution? Normal distribution is a statistical distribution that is used to represent a wide variety of variables that are measured on a continuous scale. The normal distribution is a probability function that describes how the values of a variable are distributed. It is a symmetrical distribution where most of the observations cluster around the central peak, which is over here, and the probabilities of values further away from the mean taper off equally in both directions. Extreme values in both tails of the distribution are similarly unlikely. In a quality environment, examples of normally distributed variables such as time to accomplish a task, or measurement errors, or dimensions of mechanical parts. The following picture depicts a typical normal distribution curve. So let's jump into the properties thereof. The normal distribution curve has several important properties such as symmetrical around the mean. The curve needs to be single-peaked and bell-shaped. The mean, median, and mode are in the center. The width of the curve is determined by its standard deviation, and the tails of the curves are asymptotic. The normal distribution is symmetrical about the mean. It simply means that the curve on either side are mirror images of the other side. To the left of the curve, it indicates that 50% of the values are less than the mean. To the right of the curve, it indicates that 50% of the values are greater than the mean. A normal distribution has a peak with the curve descending symmetrically on either side. The height of the curve indicates that most of the values of the population falls near the central value. For obvious reasons, the curve is often described as being bell-shaped with its edges that flares out. All normal distributions have the same basic shape, but they may have different locations. Central tendencies of the curve. A measure of central tendency is a summary statistic that represents the center point or typical value of a dataset. The three most common measures of central tendencies are the mean, median, and the mode. Each of these measures calculates the location of the central point by using different methods. When you have a symmetrical distribution of continuous data, the mean, median, and mode are approximately equal and lie directly in the middle of the distribution due to its symmetry. Standard deviation versus the width of distribution if the mean is the same. The standard deviation is a typical difference between each data point and the mean. In the example in front of us, we'll see that in both images that the mean is equal to 100. So let's look at the graph on the left-hand side. You will notice that the width of the distribution is narrow due to the values in the dataset being grouped closely together. However, the graph on the right-hand side, the standard deviation is 15. The width of the distribution is wider due to the values being more spread out. Therefore, in conclusion, the width of the curve is determined by the standard deviation of a distribution. And finally, the asymptotic tails. In simple terms, the tails of the curve flattens out indefinitely, but it will never touch the x-axis. Therefore, the curve is asymptotic to the baseline. There are two very important parameters to determine a normal distribution, namely your mean, which controls the location. It defines the location of the peak for normal distribution. Most values cluster around the mean. On the following graph, changing the mean shifts the entire curve left or right on the axis. The second parameter is your standard deviation. On a graph, changing the standard deviation either tightens or spreads out the width of the distribution along the x-axis. A large standard deviation produces distributions that are more spread out, which could be depicted in your green graph. Let's jump into the rules. This will be statistical rule number 1. The total area under the normal distribution curve sums up to 1 or 100. Or 100%. In layman's terms, it means that the area under the curve defines the probability that a randomly selected observation will take on a value within a specified range. It should also be noted that proportions of the area underneath the curve that are contained within plus minus your 3 standard deviations of the mean can be extracted from the statistical table. So let's take a look at the second rule of normal distribution, also known as the empirical rule, which is known as 3 sigma rule or the 68, 95, 99.3 rule. So how can this rule be used? The empirical rule can be used to determine the proportion of the values that falls within a specified number of standard deviations. You can use it to determine the proportions of the values that fall within a specified number of standard deviations from the mean. So many words, but let's put it on a diagram. Basically what it means is that 68% of the observations will be within 1 standard deviation on either side of the mean. 95% of observation lies within 2 standard deviations on either side of the mean. And 99.7% of the observations will be within 3 standard deviations on either side of the mean. The area under the normal distribution curve can be written as follows. The table in front of us is basically just giving us the information that was extracted from the diagram. We are now going to work through an example that will demonstrate how you can utilize the rules of normal distribution in a quality control environment. A protein shake manufacturer in Cape Town packages healthy and delicious protein shakes in 1 kilogram packages. We need to keep in mind that 1 kilogram is equal to 1,000 grams. The quality controller on the process line weighs a random sample every hour for a period of time as part of the checks and records the mass. The mass from 100 samples follows a normal distribution and ranges between 922 grams and 1,070 grams. I would like to use Excel to show you how easy it is to determine the mean and standard deviation of a dataset. We would then determine the data points by making use of the formula. So let's jump to Excel. The data in front of us are the recorded masses of the 100 samples. The formula that we are going to use to determine the data point at each one of the standard deviations will be the data point is equal to the mean plus minus your standard deviation. Plus minus simply due to the fact that to the right hand side of the mean, your values will be greater. And on the left hand side, 50% of your values will be less than the mean. So let's jump into it. It's going to be quick, easy peasy. So to calculate your mean is equal to your average. Open up your bracket, and now you'll select all your data. Okay, close your bracket is equal to. You've now found out that your mean is equal to 997.43 grams. Now, when calculating your standard deviation, you'd need to keep in mind that the mean and standard deviation are parameter values that apply to an entire population. However, population parameters are usually unknown because it's generally impossible to measure an entire population. However, you can use random samples to calculate and estimate these parameters. So when calculating standard deviation, you need to use the correct formula. It's there. You need to go down to the sample. Open up the bracket. Then again, you need to select all the data. Close. And voila, there you go. So your standard deviation is 41.23 grams. So let's calculate the data point for your first standard deviation on either side. Equal to your mean plus your standard deviation. First point is 1038 on the right hand side of your curve, and on the left hand side will be equal to your mean minus your standard deviation, and is equal to. So you'll be doing this for all of your data points. Alrighty, so you have all of your data points and all the necessary information. So let's put this onto your curve. So now you do have your normal distribution curve in front of you, and we have plotted our mean, which is right in the center, and your data points on either side of your mean. So suppose that the target amount is 1000 grams. What percentage of the bottles will have less than the advertised amount of protein shake? The yellow line represents your target value, which is 1000 grams. So we have all of this information, but what is it actually telling us? Oopsie-daisy. It's telling us that only 40% of the protein shakes being produced, the customer will receive what they paid for and more. And 60% of the customers will not receive the correct weight. My goodness, I can only imagine all of those angry people out there. So what are we going to do to fix this? At the end of the day, we would like to give the customer what they are paying for. We wouldn't want to cheat them out of it. So how do we fix this? The company can change the mean to make it equal to the target value of the product, making it higher in order to have more conforming products. Or on the other hand, they could adjust the accuracy of the machine to weigh the desired amount and decrease the standard deviation, which is also affecting your variance. Now, you always need to keep in mind that variation is the enemy of quality. Righty then, so we have reached the end of our screencast. I hope everyone enjoyed it, and I hope you have learned something about normal distribution. We would like to make a note that most of the images used in this presentation has been created by the group members of Quality Geeks, and the pictures that we couldn't use we downloaded from www.mathsisfun, as well as www.pixabay.com. There are free websites that you can use to download free images. So thank you very much and good luck.